This is our next discussion out of section 1.2. We're talking about scatter diagrams. Scattergrams, as your book calls them, are just plots of a bunch of ordered pairs. The ordered pairs may or may not be related to one another, but usually they are. And when they are related to one another, one of the things of interest is that we're going to look at the patterns that may exist and learn from those via the visual representation that we see in the scattergram. So the points are going to show us maybe possibly very important information, and that's the reason for learning how to do a scattergram. So we're going to do this using the example over here on this side of the page, on the right side of our page on the notes, and we're going to be looking at values of an independent variable which represent the value of a bill, like a dollar bill or a $5 bill, $10 bills, and $20 bills, and $30 bills. And the dependent value is representing the average number of years in circulation. And these things are definitely related, and it should be obvious to you that they are. But I'm going to spend just a tad bit of time talking about how they are related. So, for instance, if we have a dollar bill, we use dollar bills all the time, and therefore the rate at which we go through them is quite substantial. So a dollar bill may be out there in circulation only for a short amount of time, because it's going to get worn out a lot faster because it does go through so many hands in a day. Now, the larger the bill gets, the less frequently they're going to be used, and therefore the larger the number of average years they're in circulation. For instance, in a $50 bill, you rarely see $50 bills. You have to actually go to the bank and specifically say, I want a $50 bill. And those $50 bills, therefore, they're not going to travel from hand to hand quite as often as a 20 or a 10, and therefore their average life is going to be longer. All right, now we're going to go ahead and graph these things. We're going to use this graph over here on the right-hand side as an entire first quadrant, because all of our values are both positive x's and positive y's. So I'm going to use the scale down here as, I think, 1 to, or by tens, or by fives. Let's go by fives. So this is going to be my 0 point down here. I'm not sure why I don't have any writing skills here. So 0 over there, and then this one is a 5, and then this one is a 10, and 15, and there's our 20, and then 25, 30, 35, 40, 45, and there's our 50 scale. And then up here, I'm going to mark these off by half-year increments. So that's 0.5, and that's 1, and that's 1.5. There's 2, 2.5. There's 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, and 9 would actually be off my scale. So I'm just going to break my scale right here, and I'm going to put 9 up there so that we get the point. I don't have the opportunity just to add to this right here now. So I'm going to go find 1, which, remember, I could break this down into 4 little increments. So let's see, about 1 would be about right there. And so I would use that 1 to go up and find 1.5. So 1.5 would be approximately right there. And I'm having a hard time doing this, as I do sometimes with this. So 1.5 is right there. And then 5 and 2, which is right there. And then 10 and 3, 10 and 3, which is right there. And then 20 and 4, which is right there. And then the next one, the last one that we have here, would be 50 and 9. So 50 and 9 being this one up here. And now you know that we really should put the ordered pairs. I'm about out of time, so I'll just put these as a start here. But that would be a scatter diagram of these particular ordered pairs. And one of the things that I want you to notice about those as I finish writing ordered pairs here is that these things are showing us